Yeah, and just to add some further context to Nick's story, this would have been occurring around the 2018 or the start of this conversation. And at that time, very famously, Airbnb basically went back to native. And so there was a lot of skepticism about React Native and performance at that time. And Coinbase, most of their revenue come from their retail mobile applications. So people were very sensitive about look and feel, performance, and it was a pretty intense thing to just go all in on React Native. So just to add those kind of things to Nick's story. So Nick, tell me a little bit about just generically when you're dealing with an app like Coinbase, you have a very complex potentially data layer. What are the things that cause performance issues, and what did you learn from dealing with them with the React Native rewrite?
For sure. So like at first it was actually great. For the first, couple screens, the app performed great. It was just you would write code and out of the box everything would be good. But then like I don't know, as you started adding more screens, more surface area, more complex features, it was like a slow degradation of performance, and then it just started like accelerating, and it kind of like went exponentially bad. And that was like kind of a terrifying moment, particularly for me, who was like championing this. It's like, oh, we've made a terrible mistake, and we are so deep right now. I cared a lot about this, so I was kind of assigned the task of like trying to figure out why and how to fix it. And at that point, it was I feel like when we adopted React Native at Coinbase, it was kind of like right at the tipping point where React Native was kind of like ready for prime time. Before that, I think it was like a little too rough around the edges, but still like there wasn't like that much expertise. So you couldn't just Google it and be like, oh, this is the problem. It's like you kind of had to figure it out. So the first step was just kind of like building instrumentation. I think we built like a what's it called again to basically like wrap every function component and then put like an instrumentation to capture like the number of renders, like the time spent rendering, and then like have like a higher order provider that would just sort of like aggregate that data, and then you could once you had that, then you could group and sort and slice and dice and sort of like understand what you were dealing with, because the user experience was just kind of like you'd press a button and then there would be like no response for a second, and eventually it would work and you'd be like, well, that sucks, but why? And it was very obvious that it was like a holistic problem. So it wasn't like a, oh, it's clearly this or this. It was just kind of like the whole thing felt slow. But once we had the instrumentation, then and we could sort of like sort to see like where the most problematic areas were, it became apparent that like the main problem wasn't how much time things were rendering. It wasn't that like the screen itself takes a long time to render. It was the number of times we were re-rendering. So if you would look at the counts, you would see like all of these like small components that were, maybe they only took us a millisecond or two to render, but they might render like 1,000 times over the course of a session. So when you add that up, that's an enormous amount of processing. And that mapped very clearly to the frames per second. So in React Native, it's you have two threads. You have the UI thread, which is sort of the native Objective C or Java thread, and then you have the JavaScript thread, which is pretty much all the code you're writing is the JavaScript thread. And you pretty much never have to worry about the UI thread for the most part. Like that's hyper optimized, fast languages maintained by Meta. So it's if there's an issue, it's in the JS thread. And what you would see is like when you would press a button or something and you get the jank, the JavaScript FPS would drop from somewhere in the ballpark of 60 down to like two, or sometimes it even went negative somehow. And so like that became the name of the game of like keep that JavaScript FPS as close to 60 at all times as you can. And then that was sort of like the began the journey of like, okay, now that we know that is the core problem, how do we solve that?
Yeah, and just to also add some further context, right? Like there's state that lives in the native side of things, and there's state that lives in the JavaScript side of things, and there's a bridge, basically, traditionally. I don't know if they've put in the new bridge or, all that kind of stuff that's happening recently.
Oh yeah, I think it's there allegedly. I don't know.
It's
It's hard
allegedly,
to
there's
keep
a,
track
there's a
of
lot
these
of
things.
conversation about that, but you'd have a lot of traffic going back and forth. The JavaScript thread where all the business logic would get locked up, and that would actually cause the whole app to stutter and kind of do it. So this sounds like there was a lot of data state changes causing these re-renders. Is that right, Nick? Can you tell me a little bit about maybe how that would happen and maybe one particular screen that was really gnarly in the Coinbase app that was hard to kind of port over?
Sure, yeah. I wouldn't say that there was like any particular screen that was like
Yeah.
really problematic. It was just everything. And it was like the first thing was uh, pretty easy to do. Actually, I mean, it was laborious, but otherwise straightforward, which was just memoizing everything. So up until that point, we weren't really taking advantage of React Memo or like all the use callback, use memo, companion hooks that come with it. Um, and so that was just that was step one, and that got us a really long way. So just memorize all the things, and just for like a very brief background on how React works. By default, like every component is a function and receives an object of props. And out of the box, React will just sort of render like anytime it does a render pass, it'll just render everything. If you memoize, which is you just wrap the function component in a memo call, then it'll like perform a check, a shallow equality comparison to see like, okay, are the props different this time than last time? Um, if they're not, then we won't have to re-render this. No big deal. But that gets a little bit more tricky because of the shallow equality comparison. You end up, if you change the identity of an object or a function, that will trigger like an invalidation of the cache. So you have to be very careful that like everything you're passing in is like stable. Anyway, that got us like a long way, but not the whole way. There was also an issue with like the data layer we were using was context based, and a characteristic of context in React is that like anytime the context changes, everything that's subscribed to that context will then trigger a re-render, regardless of memoization. It overrides memoization. And because we had a single like global data store, basically anytime you would update anything. So imagine you're fetching like prices every, 5, 15 seconds, whatever. That might like trigger a re-render of like the user avatar because they're subscribed to the same context. So it's just like exacerbating like the re-rendering issue. So that was like another thing that we had to work through. Just like stabilize all the things and then like have more like surgical re-rendering. Um, and the other big one was due to like the difference in like the way navigation
Right.
works on web versus mobile, which is it seems like a small thing. It's actually like one of the bigger learning curves of React Native in my experience.
Yeah, I mean,
What were you
I
gonna say
was
here?
about to say, like, if you look at the Coinbase application, you've got like a whole load of tabs with lots of widgets that are sucking down a ton of state, right? You've got like the
Yeah.
price of the different assets, your portfolio, maybe some other kind of like NFT related stuff that you're looking at these days. God only knows what. So you're just pulling down tons of stuff that would cause a render. But tell me a little bit about like navigation and what's tricky about that. Like, because that I think is another interesting and subtle difference from, browser land, where basically a lot of that stuff you don't really have to worry about as much.
Yeah, for sure. It's like everything is comparatively like ephemeral in browser land. Where it's like, I mean, it's, there's a bazillion ways to render a web app these days, but like in a simple like SSR case, right? You navigate to a page, here's your HTML, maybe we'll hydrate and maybe we won't. And then maybe you navigate to a different page, same thing. But you're kind of like you're only viewing one page at a time. And then even if you have a client side single page app, it's you might have like a sort of a persistent data layer, but you're only rendering like one page at a time. And then once you navigate away, then the previous page is kind of gone. With a mobile app, you are simultaneously mounting many pages or screens often. So, like in the example that you were just talking about, Harry, you have 4 tabs at the bottom, 5 tabs. Then, at a minimum, you have one screen per tab, but then each of those is probably a stack too. So they can also have like depth. So you could have like 2 or 3 or 4 even of each of those screens mounted. So now you're talking maybe at any given time you have maybe 10 screens mounted. So if you have like a state change that triggers like a re-render, you're not just paying the cost like on that one screen, you're paying it across like all of those screens. And to boot, you're doing it on a low powered device. You're doing it on like a tiny iPhone running like JSC versus, a MacBook M2, in Chrome. So it's expensive.
And so, what was the solution to that? Like navigation libraries? Was there some kind of things that you could do? Can you tell us a little bit about that?
Yeah, thank God there's a better solution than what we did now. At the time, it was we figured out this was the problem, but there wasn't like a solved way there wasn't a solution available. So it took a while to like a lot of tinkering to find a workable solution. At first, you could just say like, stop rendering the content. Like say you're an unfocused screen, just like render a blank page, and then like there's nothing even to re-render, which works and significantly improves performance. But the issue with that is you navigate back to the page or screen, and you've lost all the state, right? Like maybe you had a scroll position, maybe you had like form input or something. That's gone, so that's not workable. And then I tried like a suspense based approach where I would if you were an unfocused screen, I would throw a promise that would be resolved once the screen was refocused. And that had the outcome of like retaining state on like form inputs. So if you entered your name and then switched screens, came back, your name would still be there. But it did not retain the scroll position because like one is sort of happening in React land and one is happening in native land. And so you would come back and it's like, oh, I was scrolled down, now I'm scrolled up. So that wasn't good. What we ultimately landed with was a solution where it's like uh, the data layer, it would on unfocus, it would swap out the current state of the data layer and feed the because context in React is hierarchical. So if you have like your global data layer and then like every screen has a sub data layer, and if it's not focused, it gets a frozen state that it last saw the last time it was focused, then anything can happen up here and this won't care. All of its children will care. And then whenever it gets focused, then you re-swap in the fresh one. And that was the solution that like actually worked, retained the scroll position and all that stuff. Now, thankfully, there's I think it's like React Freeze or something like
Mhm.
that, which basically solves the problem, I believe, at the native layer. So you don't have to do like the fancy, context magic to get it to work.
It's nice that progress is being made and you don't have to do these janky workarounds. Now, obviously, with React Native, I would be remiss if I didn't ask about Android versus iOS performance issues. Was there any kind of
For
differences
sure.
that you encountered there and problems that you had to overcome?
Yeah. Well, I would say just in general, like React Native Perf is more or less just React Perf. It's just hard mode because, like I said, you're working with like a lower powered device, and there's just like issue like networks are going to be slower. You're going to have connectivity issues. It's just like harder. Um, and I would say that like iOS versus Android, Android is like the hard mode of React Native performance. You're just kind of like working with software that's like more varied, less predictable, often like less powerful. Um, so yeah, it's just I wouldn't say that there's like anything fundamentally different with regard to like how we approached it. It's just you have to be like if you can make an app performant on Android, iOS is good. Like iOS was going to be more than fine. It's going to feel great. So like my advice is just which is what we did for a while, build against Android. And if you can make that feel good, then you're doing great.
Yeah, and that's because you've got like a wider variety of devices that you have to support. And you can do things like limit the amount of devices that you roll it out to or the types of them. So it's kind of skewed towards more performant things. But generally, yeah, if it's working good on Android, it's probably going to work pretty awesome on iOS, is kind of the rule of thumb.